Hey, looking at some of our Chapter 4 review, this video is on just that first section, right triangle trig, out of section 4.1 in our book. Hey, first, if I don't get around to fixing this, I'm going to try to. You need to change your number 1. The dimensions in it were wrong. It originally said 2 root 5, but it's supposed to be 2. I'm sorry, it says 2 root 4, but it should be 2 root 5. So you need to fix that, because otherwise this problem would be wrong. Alright, so make sure that this thing right here is actually a 5 and not a 4. To answer the rest of the questions, this is a trig function question, and this is using good old SOHCAHTOA. So SOHCAHTOA, make sure you spell it right. If you misspell SOHCAHTOA, it's really going to mess you up. So sine is opposite over hypotenuse, so my opposite is 2. This is my angle theta right here. So opposite is 2, and the hypotenuse is 2 root 5. The 2's will cancel, making it 1 over root 5. And I am personally okay with that. I think rationalizing denominators is weird and unnecessary. However, if this were a multiple choice question, I very well may rationalize, so you need to know how to do that. So we would multiply top and bottom by root 5, which 1 times root 5 is root 5, and root 5 times root 5 is just 5. So I would accept either 1 over root 5 or root 5 over 5. It does not matter to me. Just you need to know how to rationalize, just in case it does show up as a multiple choice question. Okay, so cosine is adjacent, which is 4, over the hypotenuse, which is 2 root 5. On this one, I will reduce 2 and 4 cancel to 1 and 2. So this thing cleans up to 2 over the square root of 5. Or if you rationalize that, it will be 2 root 5 over 5. Either one is fine with me. Tangent is opposite over adjacent, so opposite 2 over adjacent 4, 2/4, which reduces to 1/2. And then for cotangent, secant, and cosecant, we just start reciprocating. The reciprocal of 2 over 1 is, of 1 over 2 is 2 over 1, or just 2. Secant is the reciprocal of cosine, so since I know what cosine is, secant is the reciprocal of that. So I'll flip my cosine to get root 5 over 2, and then sine and cosecant are reciprocals, so the cosecant would be, if sine was 1 over root 5, cosecant is root 5 over 1, and there we go. Then the last thing, I do ask you to find the angle measure, the degree measure for theta. So we need to do that. And that is a calculator question. You're definitely going to have to punch this in the calculator. So let me pull out my calculator. Okay, so we're going to punch this in the calculator. The first thing you need to do is it does specify to find the degree measure for theta. And I put degree there for a reason, because I want your answer in degrees and not radians. So looking at my calculator, here's my calculator screen. I'll go ahead and clear that out. Make sure you're in degrees. So I'm going to hit the mode button, which you can see the tip of my finger right there is my mode button. So I'm going to hit that and make sure that degree is highlighted or selected. If you're on a TI-89, you need to change your angle to degree. I'm already there. So now the problem is for me to be able to find the angle, and you could actually choose any one of these 6. Actually, I would choose one of the top 3, and tangent is my cleanest one. So to solve for theta, I know that tangent of theta is equal to 1/2. Is equal to 1/2. And that means if I want to find theta, we will do the inverse tangent of 1/2, and we'll simply throw that in the calculator. So let's go back to the calculator screen, and the inverse tangent, so inverse tangent of 1/2, simply type it in like that, hit enter, and our angle is 26.565 degrees. And I am a fan of 3 decimals, so make sure you do round your answers to the 3rd decimal. Where's my calculator again? There it is. So we will put this as our answer here, and we do get inverse tangent of 1/2 is 26.565, and that will be our angle measure here, 26.565 degrees. So there's our theta. Yeah, so find the 6 trig values, and then just do the inverse trig of one of them. It doesn't matter which one you choose to get your angle measure. All right, so let's look at number 2. Same type problem. Again, we're going to use SOHCAHTOA. Sine is opposite. Here's my angle theta, so sine is going to be opposite, which is 24 over hypotenuse, which, dadgummit, how many mistakes am I going to make? Your hypotenuse cannot be 13, because then your hypotenuse would be shorter than your leg. The hypotenuse here is supposed to be 26, so change that to 26. Man, I'm making mistakes all over the place. So Change that to 26, and that does reduce to 12/13. Your cosine is adjacent over hypotenuse, which is 10 over 26, which will reduce to 5/13. Tangent is opposite over adjacent, so 24 over 10, which is 12 over 5. And then once I get those three, we simply start flipping them. Cotangent is the reciprocal of tangent, so 5/12. Secant and cosine are reciprocals, so secant is 13/5. And then sine and cosecant are reciprocals, which means cosecant is 13/12. So there are my 6 trig functions. Now I simply choose one of these top 3, and the reason I choose one of the top 3 to solve for theta is because your calculator has native sine, cosine, and tangent buttons. The cotangent, cosecant, and secant are tougher to find. I'll just choose, I don't know, we'll choose cosine. If I know that cosine theta is 5/13, I could say that theta is the inverse cosine of 5/13, and we will simply throw that in the calculator. So let me go to the calculator. The inverse cosine of 5 over 13, hit enter, and there's our answer. Let me copy that onto our screen. And we get an answer of 67.380 degrees. And I do like 3 decimal places, so 67.38. Even if your third decimal is a 0, I would appreciate it if you wrote that. And that is in degrees, so let's put the degree symbol there. Good? Good. All right, let's see what else we have. Find the remaining 5 trig functions given this information right here. So let's see, we have the sine is given to you, so that's 2/3. And what I could actually do is I know sine and cosecant are reciprocals. So if I know sine, I automatically know that cosecant is 3/2. The problem is your remaining 4 trig functions. And the way we're going to solve this one, since we don't have a triangle to look at, and this is not on the unit circle, what I'm going to do is I'm going to draw a triangle. And I will label it such that I just pick some angle theta. We'll put theta right here. And I know sine is opposite over hypotenuse. So I know that my opposite side has to be 2, my hypotenuse has to be 3, and then I'll use Pythagorean Theorem to solve for my adjacent side. So a squared plus 4, which is 2 squared, I'll just write 2 squared, is equal to 3 squared. A squared plus 4 is equal to 9. Subtract the 4, you get 5. And then you take the square root, and you get a to be the square root of 5. So now that I know what a is, I can answer my other 4 by using SOHCAHTOA. Cosine is adjacent over hypotenuse, so that'd be root 5 over 3. Tangent is opposite over adjacent, and I'm okay with the radical in the denominator. Cotangent, now we start flipping. Cotangent and tangent are reciprocals, so cotangent is root 5 over 2, and in cosine, it is the reciprocal of secant, so secant is going to be 3 over the square root of 5, and we're done. Find the remaining 5 trig functions. We did that. It did not ask you to find the actual angle measure for theta, so we'll stop right there. Let's see, same problem. I give you tangent is root 5 over 6, and if I know what tangent is, I can reciprocate that and get my cotangent, 6 over root 5, but my other 4 are going to depend on that triangle. Since this is not on the unit circle, I will draw my triangle again, so leg, hypotenuse. I'll pick some angle to be theta. I'll put theta right here. And tangent is opposite over adjacent. So root 5 over 6. And then we need to find the hypotenuse. So 6 squared plus root 5 squared equals my hypotenuse squared. 36 square root of 5 squared is 5. 41 is h squared, which h ends up being the square root of 41. And so now that I know what h is, I know my hypotenuse, I can go on and find sine, cosine, and their reciprocals. Sine is opposite root 5 over hypotenuse, root 41. Cosine is adjacent over hypotenuse. And then we flip them. Cosine and secant are reciprocals, so root 41 over 6 for secant. Sine and cosecant are reciprocals. So root 41 over root 5 for my cosecant. So draw the triangle that fits this information. If it's not on the unit circle, you draw the triangle, and then you use your triangle to answer the remaining problems. Let's see, secant equals 3. All right, well, let me go ahead. I can fill in secant. I know that's 3. I know secant and cosine are reciprocals, so 3, the reciprocal of 3 is 1/3. And then I need to draw a triangle that fits this. Now, drawing a triangle, we don't think very well in terms of secant. So I'm actually going to change this. If I know secant is 3, cosine is the reciprocal. I just use that to get this over here. And I'm going to draw a triangle that fits a cosine to be 1/3. So let me see, hypotenuse. Oh, class is about to start. Better hurry up. Are there any problems after this one? Ah, geez, there are. I guess I will do this. I'll pause the recording and finish this later today. All right, that was about a 2-hour pause, and now I've forgotten where I was. I think we were about to draw the triangle that fits cosine equals 1/3. So I will, let's see, draw my theta. It really doesn't matter where you put theta as long as it's not a right, as long as it's not the right angle. There's my right angle. Cosine is adjacent over hypotenuse. So my adjacent side is 1, hypotenuse is 3, and then we will do the Pythagorean theorem to get that side. So 1 squared plus b squared equals 3 squared. B squared equals 3 squared is 9, minus 1 is 8. And you get b to be the square root of 8, or 2 square root 2 is how that cleans up. If you forgot how to clean up radicals, well, the step I skipped there is 8 is 4 times 2, and then the square root of 4 is 2, so it came out front, right, there. Okay, so we do get b to be the 2 times root 2, and then once you get your triangle drawn, the rest is simply SOHCAHTOA. So sine is opposite over hypotenuse, so that'll be 2 root 2 all over 3. Cosine we knew. Tangent is opposite over adjacent, so that'd be 2 root 2 over 1. Cotangent, you flip tangent, so 1 over 2 root 2. Secant we already had because we flipped cosine. Actually, we got secant by cosine by flipping secant. Anyway, and then sine and cosecant are reciprocals, so cosecant would be 3 over 2 to the square root of 2. And there's your answer for number 5. Now let's see, number 6. We are finding all the values for x, y, and z to the 3rd decimal place. I'm a fan of the 3rd decimal place. The easiest one for me is to find z, because you do know that all angles in a triangle add up to 180. So I know that z plus the 90-degree angle plus 40 has to equal 180. And when you solve that, you get z to be 50 degrees. So I know that z is 50, and I'll go ahead and label that in here since I know that's true now. So z is 50 degrees. Now solving for x and y are going to be a little bit more difficult. I like to use the information that's given. I'm going to use the 7 and the 40 as much as possible. I will avoid using any answers that I get in the problem. For 2 reasons. One is a lot of times these answers are going to be rounded, and you don't want to use rounded answers. Another reason is just the off chance that I messed up for 50. I don't want to use a mistake or a wrong answer to get the rest of my problems, the rest of my variables. So I'm going to do 40, and to get x and y, I'm going to have to set up some sine, cosine, tangent business. Let's start with x. If I think about 40, I have the opposite side, and I have the adjacent side. Well, if you have opposite and adjacent, that is tangent. So I will say tangent of 40 degrees is equal to opposite 7 over x, and then we solve that equation. I like to get rid of my fraction, so I'm going to multiply by x on both sides of the equation. Over here, the x's cancel, leaving me with x times the tangent of 70 degrees. Why did I say 70? 40 degrees is equal to 7, and then we will divide by the tangent of 40. Divide by tan 40. And then we will punch this in the calculator. 7 divided by the tangent of 40. And let me punch that in here. 7 divided by the tangent of 40. Hit enter, and you get 8.342. So 8.342 is our answer for theta. answer for x. So x equals 8.342. And I do like the third decimal. Then I'm going to set up to solve for y the exact same way. I'm still going to use 40. 7 is opposite, and y is the hypotenuse. So if I'm going to do with opposite and hypotenuse, I'm going to use sine is 7 over y. And I'm going to pause this while I work it out because it works the same way as number 6. There we go. So it solves the same way. It's just sine instead of tangent. You end up with pretty much the same thing. You punch in the calculator, and there are your answers for 6. I think there's one more. I think number 7 is the last one for this section. Yeah. Okay, so number 7, I need to find x, y, and z. Z to me is going to be the easier one because I have the 2 legs. So I'm going to do Pythagorean Theorem. 6 squared plus 9 squared is equal to z squared. 6 squared is 36. 9 squared is 81. 36 and 81 is what? 117. And you get z to be the square root of 117. And I'm perfectly okay if you leave your answer like that. If you want to punch in and get a decimal approximation, you can, but there's really no need to. Square root of 117 is good enough. And then I need to find x and y. While I do have z now, I want to use the angles or the measurements that were given to me. 9 and 6 were both given to me. I did not come up with those, so I would prefer to use 9 and 6 instead of the root of 117. So when I'm looking at, let's say, x, if we're looking at angle x, 6 is the opposite and 9 is the adjacent. And opposite and adjacent means we're going to use tangent. So I would say tangent of x is equal to 6 over 9. And then to get x, we will do the inverse tangent of 6 ninths. So the inverse tangent of 6 ninths, we'll go to our calculator. The inverse tangent of 6 over 9. And you get 33.690, and this is an angle, so x is 33.690 degrees. So there's our answer for x. And then y, I'm going to do the same thing for y, except now when I do y, my tangent, my opposite and adjacent flip. Now, if I'm looking at y, 9 is the opposite, and 6 is the adjacent. So I'll do tangent of y is equal to 9 over 6, and y is the inverse tangent of 9 sixths. We'll throw that in the calculator. Inverse tangent of 9 sixths, and you get 56.3099. That'd be 310. So we get y to be 56.310. Of course, once you have 2 angles, I did have the option of subtracting them both from 180, and that would have been fine. It would have worked too, but I just prefer to use the stuff that's given rather than a rounded answer. So there is your stuff for section 1. I will do videos for the other 3 sections as well.